right, ladies and gentlemen, I know this is a little different because I am recording the warm-up. And after the warm-up, I'm going to go over the highlights of the calculator activity. All right, we're going to find the value of each variable and write our answer in simplified radical form. That means it should still be a square root sign, right? I know we're having some hard times with that. Okay, we've got the 30. That means my leftover angle is 60. And now 30, 60, 90 triangles are special. So my person that's doing 30, 60, 90, which I think is David, a 30, 60, 90 triangle is special. And you should have seen on your calculator activity, across from the 30 degrees, we call that x. It's the smallest side. Across from the 60 degrees, we multiply it by the square root of 3, and that will give me the answer. So the smallest side times the square root of 3. If we take the small side times 2, we get the hypotenuse. So for my 30, 60, 90 triangle, this is all the picture I need. That's it right there. So we're going to solve these things. All right. I don't have my smallest side. It says y. Okay. I don't have my second longest side. It says x. The only thing I have is my hypotenuse. How would I get from 12 square root 3 back to x? Now it says right here it's being multiplied by 2, so what do you think I do? Divide by 2. So 12 square root 3 divided by 2. Okay, which ones are like terms? Does 12 and 2 or 2 and square root 3? How many times does 2 go into 12? Excuse me. 6. It goes in there 6 times. So 6 square root 3 is going to go where? I found x. So let's look at where's angle 30? What's across from angle 30? X or y? Y, across. It can't be connected to it. So 6 square root 3 is y. Okay, how am I going to find x? Right here it says across from 60 degrees, I times it by the square root 3. So what am I going to do with 6 square root 3? Times it by the square root of 3. So I get 6 square root 3 times square root 3. What's square root of 3 times the square root of 3? 9. What is the square root of 9? So 6 times 3 gives me 18. How do we feel about this? Okay. We are going to, this was what your homework was last night. And this is what that packet is. Now, there's definite proof that if you discover this yourself instead of me just telling you, you're more likely to remember it. And when you get to things like your ACT or your MME, you're going to be like, oh, I remember that stupid calculator activity we did. What was it? What did I discover about it? So that's why we're doing it that way instead of me just telling you how to do it. I'm going to put up here the 45, 45, 90 triangle. Okay, so this is 90. This is 45, and this is 45. Anybody who completed the second page of their calculator activity want to help me out with discovering what is special about this? And these are degrees, by the way. I know I have a problem leaving off those little circles. What do I know about a 45, 45, 90 triangle? Yes?
That it equals 180.
The interior angles equal 180. What do I know about the sides? What did I discover? I see some people have this sheet in front of them and they told me they were done. So I want you to turn to the second page. Anything you notice about 45, 45, 90 triangles when you did this activity? The legs equal each other. These are both going to be the same length. We know that for 2 reasons. One, your calculator activity, but also, you guys remember base angle theorem? If both angles on the bottom are congruent, then both the sides are congruent. Yes? You are on that paper in marker so I can see it from the back of the room. Okay. From your calculator activity, did you figure out anything else? What about the hypotenuse? How would I find the hypotenuse for these? Well, let's think about it. We know all of these will work through Pythagorean theorem, right? All right. So x squared plus x squared. How many x's do we have?
2.
And they're both x squared, right? So we have 2x squared. All right, all right. What do you think? What would be the first thing we do to get x by itself all alone? We'd have to divide by 2 first, right? And then we'd have to take, so we've got this 2, and it's gone. But we don't really know it's over here. We're left with x squared, and we've got this dividing by 2 over here. And then we take the square root of both sides. Huh. Any ideas? We know we're going to have the square root of something, right? And we know we're going to have to do something with the leg in order to get it. We've got the lengths of the legs times the square root of 2. Gives me that hypotenuse. Okay? When you're doing your calculator activity, you've got a whole chart, right? Where you're given legs. So, for example, if I've got leg 1, leg 2, yours are labeled A, B, C, right, whatever. If I have leg 1 is 2, what's leg 2? 2. And now, what would the hypotenuse be according to this? If we've got x is 2, the hypotenuse would be 2, what? Thank you. 2 square root 2. That's what that whole calculator activity is about, is figuring out that if you know what the leg is, you times it by the square root of 2. That's the whole point of that activity. Okay, so ladies and gentlemen, we have learned a lot of stuff that we're going to take this quiz tomorrow. Okay, we know that a right triangle, we can prove it by Pythagorean theorem. A squared plus b squared equals c squared. We know if a squared plus b squared is greater than c squared, it's a cube. And if we know a squared plus b squared is less than c squared, it's obtuse. We know what a hypotenuse is. It's across from the 90-degree angle, and it's the longest side. We know what the legs are. They're the ones that aren't the hypotenuse. Right? We know a Pythagorean triple always has to be a multiple or a factor of 3, 4, 5. We know the converse of the Pythagorean theorem. If a squared plus b squared does equal c squared, it has to be a right triangle. We've learned all about the geometric means. The square root of AB equals the altitude. We've learned different theorems about similarity, how to set up those similarity parts. We know what an altitude of a triangle is. It goes from the hypotenuse to the 90-degree angle. That's the altitude of a right triangle. We have also learned what a 30, 60, 90, and a 45, 45, 90 is. I am going to check your vocab tomorrow. You will get a point for it. If you have all of those words that are up there and all of their definitions, I know not all of their pictures are up there, but they are in all of your notes. And we're going to put some more of those pictures up there in just a second. Okay? So, today, what you need to get done in class by the end of the day, or at least by the beginning of tomorrow, is if you have not finished that geometric means paper, that needs to be done, that calculator activity. You need to finish your 30, 60, 90, and 45, 45, 90 special right triangles calculator pack. You need to, I'm going to do that in a second, you need to have your vocab done, and today I am going to pass out your review. I know this sounds like a lot, but you've had 2 days to do the geometric means. You've had a day to do the special right triangles. I was hoping this whole hour today you would be spending just working on your review, but if you haven't finished something, you should finish that first and take that review home for homework, and we are going to go over it. Right now, what we're going to do is go over last night's homework. So if you could get that out. We're going to go over that. Once we're finished with that, you'll have the rest of the hour to work on those calculated activities or your review. 1 second, please, honey. I am in the middle of recording.